Hey class, today I'm going to be talking to you about intercepting and tracking on navigation systems. We're going to start with NDBs, or non-directional radio beacons. NDBs are a ground-based radio navigation system. Require an ADF needle to be able to track. And tracking a NDB requires interpretation of the wind and drift angle to track on course. So if we're this plane over here, we'll be tracking straight north to this NDB. If the wind's coming in this way, and we're straight on that blue course, and if we continue tracking directly north, we're going to find ourselves drifting over this way. And down here on our ADF, we're going to get a deflection needle that's going to point this way. We're going to start drifting away from that course. To retrack that course, we're simply going to turn in the direction of our needle to re-intercept that course and get back on our north heading. If we hold that correction in, we're going to be able to crab into the wind and just continue tracking on our course. Intercepting on an ADF is going to require turning the course knob to the desired heading and bearing within accordance of the station. And in order to intercept, you're going to want to find your deflection between your desired course and your aircraft. So for example, if you come over here, we're going to use the general rule where you want to take your intercept, multiply it times 2. So if we're this plane over here and our course is this line, if we're at a 20-degree angle from it, we're going to want to double that to a 40-degree intercept, direct back to the course in order to intercept that course again. There are a few errors with using the NDB and ADF. Not updating your heading indicator to match magnetic compass can cause incorrect tracking. Also have to be careful not to make tuning mistakes or have bad orientation. Second type of navigation we're going to talk about today is VOR, very high frequency omnidirectional range. VORs are the main source of navigation in the U.S. aerospace system, and they are radio based. They're going to give a to from indication on the flag, and with our VOR receiver along with an antenna and our ground base, can be able to know our position based on that ground station. Also have a OBS or omni-bearing selector in order to select a specific radial on that VOR station. VOR produces 360 radials outbound, and then that can also be tracked inbound. And most VOR receivers will also have a CDI or course deviation indicator to guide us to our course. So if we're tracking this course to our VOR down here at the 180 degrees, so directly south, we're going to select that in our OBS using the knob over here. We're going to spin it so that it indicates our 180 here. And if you notice, if we're directly tracking, we don't have any warning flag here. We have an arrow pointing to 2, indicating that we're direct to the south to that VOR station. And that keeps us tracking. We can always select a specific track with the OBS in the given direction to the VOR. Now, intercepting a VOR is very similar to the NDB interception. And because we do have a CDI, if our aircraft is over here and we're tracking inbound south to the VOR, our CDI is here in the center, and it's going to drift in this case it's going to drift over to the right, and we simply just have to turn towards it to intercept it until we're lined back up on our CDI to be tracking directly into that south heading again. Now with VORs, there are also a few errors. If it is not tested and set, there can be accuracy errors. Also can make the mistake of tracking in the wrong direction, so be sure to check from your to from flag. And then also failure to recognize station passage and overshooting the actual station. When you get to the station, you're going to have a course reversal of the needles. That's going to indicate that you're directly over the station. Also have to be careful not to chase the CDIs. It's going to become very sensitive as you get closer to the VOR station. Alright, and finally we're going to talk about GPS. GPS is the more modern system, uses satellite navigation, constellation of 24 satellites, and to have a good accurate reading for a 3D picture you need at least three we need at least 4 GPS satellites, and then to do away with error you need 5. And GPS is going to have a more electronic component, going to be run usually through a flight data computer, through a digital display such as the G1000 or other advanced navigation system. And with the GPS tracking, you have the unique ability to create a direct course in between two places. So real quick here, if we have airport A down here and airport B, we want to go to airport B. In order to track a course, all we have to do is put it into our GPS and hit direct, and it's going to plot a course from airport to airport. And even if we get out here, even if we were out here somewhere and we find ourselves out in the middle and we're not sure where we are and we need to track, we can always go direct to an airport via GPS positioning. Now, as far as intercepting goes, it is also very similar to the other methods. And with direct functions and advanced navigation systems, you can always just go direct and find your way to both track and intercept a course. However, if you want to follow an existing course or intercept an approach or something like that, and you're departing the airport this way, in order to get back on course, you're going to have to come back around this way. Now again, a GPS electronic system is going to have an advanced CDI system. So if our airplane is tracking here and we want to intercept our blue course, our CDI here is going to show the course as being deflected, and all we have to do is turn towards that course and line it up on our CDI in order to get a nice straight line again. And some GPS errors when tracking and intercepting GPS. You can have loss of satellite coverage, although that here flying in Virginia, that's going to be very rare. You can also have interferences. So in conclusion, this is a brief overview of tracking and intercepting courses for traditional methods such as NDB and VOR, as well as more advanced and electronic options such as GPS.